Hello, this is Chris Moberg, and I'm bringing you the next in my series of quantum training videos. In this video, we'll be looking at vehicles that are a challenge to dyno. These come in really two different veins. On the one hand, we have vehicles that have very peaky torque, um, and in the other, we have those that have acceleration that is very nonlinear. And so what we have here on the screen is a diesel truck, and it's sort of got both characteristics. Not very linear, and it's certainly very peaky. And so when you think about how you would go about loading this vehicle, you have the various load models available to you on the gear roll. These include static and interpolated principally, and both of those are linear. You know, the static is sort of straight line linear, and interpolated is rising rate or decreasing rate linear. So we might think that they aren't going to really be the best models for maximizing power extraction from this engine. And I can say in particular on this pull, 3 or 4 psi was left on the table at axle peak or torque peak because of those linear model issues. That, you know, getting enough load there at torque peak meant either a static load that was too high for it to accelerate normally leading up to the point, or if it was interpolated, the ramp to be hot enough or high enough at that point killed the power beyond that. So you want something that gives you both the peaks but the full curve, and therein lies the challenge of a linear model. So that's going to be my segue into when and why you would use a custom PAU test. So once again, the PAU tests all require that you have an eddy brake. You define the PAU test, the custom one, from the default test parameters, and you go to custom. And I'm going to essentially get the defaults in here. This is a spreadsheet-like table. It's got 3 channels. I think you probably only use 2 of them, X and Y. X almost always is going to be RPM, although if you did have an ECU connection through OBD2 or CAN, you might use TPS, or you might use engine load. Just one point about those, that the eddy brake is non-instantaneous in terms of its movement from X load to Y load. And so you just have to be aware of that attribute when your trigger variable is coming in from, say, the car, or even is just RPM. You may choose a load setting at a particular RPM, and then if you were to run this test, you'd see that you probably didn't get that load at that RPM because the eddy brake was ramping up to it but didn't achieve it exactly at that RPM. So you generally have to scale your numbers up a little bit so that they achieve the desired level by the desired RPM or TPS or ECU load. The downside of that is you may suffer some overshoot. So, so pick your poison really, and I think the overshoot is less of a problem than when you're on the front end of the curve and you're trying to build to the peak. If we overshoot a little bit, we're at that peak, it probably isn't going to affect it greatly. So the first thing I'm going to do is I'm going to come down and I'm going to look at my existing pull to see it starts at about 1300, ends at maybe 3200, and it's got a peak at a little less than 2. So I'm going to start it at 1300. So I want to go about 2000, right? Because that would be 3300. But I also want to have a control point right at the peak. So maybe I go 1600, 1900, 2200, 2500, 2800, 3100, and 3400. And I don't want that one. I don't want that one. And I don't want that one. But let me show you just how many you could have. I mean, it's like 100 of them. So anyway, coming back here, I think this was just a static 40%, so I'm going to put 40 in here, 40 here, 40 there, 40 there, 40 there, 40 there, there, and there. Now I'm going to start very simply with this custom test, and I'm going to go to my torque peak at 19, and I'm going to make this 55 and this 55. Alright, so you can see the little graph there. I have bumped up my load in a very peaky way right around where I know that torque peak is, and the max boost should occur. So essentially I'm going to do this in an iterative fashion. I would do this pull, I'd make sure I didn't adversely affect the overall torque curve, but I would expect perhaps my peak would go up, which was really the desired effect. I'd come back here and I'd say, well, let's see if a little more load there helps. Do I need to put more control points around that to better shape the load? And so you have to be a little bit of a load artist to go in and really shape it so that it best pulls out the load. I mean, this, I will say that this whole training video is about quantum, but many of these things were possible in Dyno Compute X. In particular, this custom test was. Some of you may be familiar with doing it. It was structured a little bit differently. But this is one of the most powerful tests you can do, and when you've got a vehicle that defies getting it to spool correctly or generate the power that it should based on its drag times or something, this is really your indicator you may need this test. And so with that, I'm going to conclude this training video. Thanks for watching.